guys, welcome back to the shop. Frank here, working on the Cub Cadet bulldozer. This episode is 14, working on finalizing the controls. I got the material for the control handles. This is a 1/2-inch ID tubing. I had this 1/2-inch rod, so this is what we use to make the stub shafts for the control. And then this will be the handles, which will slide down over the stub shafts. So I also did get the plastic vinyl handles, grips that will slide down over this 3/4 inch OD shaft. I'm working right now on the trunnions and the attachment to the trunnions. I think what I'm going to do is fabricate a couple of small square plates with 5/16 stub shafts out of them, weld those plates to the trunnion control plates, and then use those stub shafts to connect to the control arms on the control mechanism. I'm going to cut out some small pieces of flat stock. We'll drill them, weld in some 5/16 stub shafts, and go from there. I'm going to plug weld these two studs. I'm concerned that the control arms will move too much. That is, if I only need 2 inches or 1.5 inches of movement at the trunnion, I won't get enough movement at the top of the control handle with this being 5 inches down. So what I'm going to do is I'm going to allow for some adjustment. I'm going to drill 2 more holes roughly 1 inch apart, one here, and the same on here, one here, and one here. So I'll have 3 different holes on this control arm. That way I can move the connecting rod to any of these holes to adjust basically the sensitivity of the control mechanism. This will give me flexibility and allow for some adjustment. Now, before I put it together and finalize it, now's the time to do this. I'm going to weld this tab to the trunnion control arm. Looks like this. And the objective is to have the center line of this stub shaft about equal with the top of the arm here. We want the motion back and forth to be linear, not up and down. So the closer it gets to this direction back and forth, the more accurate the control will be. So I'm going to tack it right here, and then I'm going to take the clamp off and weld it. I should turn the wire feed back on when I do that. Alright, these will go into the control rods, and we'll drill a hole and use a cotter pin on the other side of it. So this is what the control rod will be pulling. On the previous bend, I used the oxyacetylene because I wanted a sharp bend. I wanted a very small, narrow hot spot so I could get a sharp bend. Here I'm going to use MAP gas because I want a more gradual curve. I need to duplicate this curve here for clearance within the frame. I'm going to cut out this section here and insert a turnbuckle for adjustment. That'll be one of the next things to do. Just let this cool. This is my setup for welding the threaded sections from the turnbuckles to the linkage rod. I'll weld this here, I've beveled the ends, and then I'll weld this one here, bevel the ends. And I'm using this angle iron as an alignment tool to keep the pieces in alignment. I know this is hanging out over here, but generally when you extend a small diameter rod, or really any rod for any round item, it's easy if you lay it down in a angle iron, and that aligns it in both axes, and then when you weld it, you can tack it, and then you can rotate it around to finish welding it, and then grind it flush. So this is right and left hand threads fit this turnbuckle. That'll give us some adjustment on the length of the rod. This is for the rear hydro. I'm getting set up to weld this connecting link to the end of the linkage arm. So the connecting link slides over that stub. Okay, I'm going to weld just like the rear hydro, this front hydro, this connecting link to the linkage rod. Got it marked for the proper length. Okay, so that gives us that control. We'll put a cotter pin through there to hold that on. Got the linkage here for the rear hydro, and it operates fine. The front hydro operates fine. So all I need to do is put the cotter pins in the connections, and then install the stub shafts at the vertical at the neutral position, or halfway between the motion halfway between forward and reverse. So about there. We want the stub shaft to be vertical, and of course that can be adjusted with the turnbuckles. So there's some adjustment there to get the shafts vertical, the handles vertical when the transmissions are in neutral. For those of you just joining here with the fun, it may be helpful. I get a lot of questions repeatedly, same question over and over again in the comments, about how the drives are set up to work and how, you know, they'll be fighting each other and where are the brakes and that kind of thing. So it may be helpful for me to just run down real quickly how the drive system is set up. I would recommend you go back and look at episodes 3, 4, and 5 where I modify the differentials and explain how they will work. But real quickly, there are 2 separate Cub Cadet transaxles and hydrostatic transmissions, one in the rear and one in the front. The differentials have been modified so that only one side drives on each one, and they're diagonally opposite. For example, this one free spins, the other side is driven. This one is driven, the other side free spins. The spiders and both transaxles, both differentials, the spiders have been welded. So each axle only drives one side. The hydrostatic transmissions are infinitely variable speed, from project about 4.5 miles an hour forward and 4.5 miles per hour backwards. I'm predicting that's about the approximate maximum speed. So each axle drives one track, and each track is independently controlled forward and reverse. So you can go both tracks forward, both tracks reverse, one track forward, and the other one reverse at the same time. I've done this because I wanted to be able to control the tracks independently, go on forward on one and reverse on the other at the same time to basically spin in place. Many of the other Dozer builds use an open differential and brakes to turn. And that works fine. And matter of fact, old bulldozers from years ago, I mean, that's how they did it. Today's most bulldozers and skid steers have hydraulic motors on the tracks, final drives. And each one drives one side, and they're independently operable, forward and reverse. So this is similar in that respect. Now there's a couple of compromises. One is the drive sprockets are in diagonally opposite corners. One's in the front and one's on the rear. They're on opposite sides. It's not ideal, but it's not, I don't believe it's going to be a major problem. My objective here is to use Cub Cadet components. That's why I didn't scavenge drives, final drives off of a skid steer or a zero turn or something like that. This is Cub Cadet. It has limitations because of that. However, I don't think they are major in that I think the final result will still be a neat looking toy. So that's why I've done it this way. Hope that answers your questions. I do suggest you go back and look at episodes 3, 4, and 5, and you'll see the transmissions being modified, exactly how I did it, and that may answer some more questions. Okay, I'm going to go ahead and put the pins in the linkage here, and then we'll set up the stub shafts and weld them on. I found the center. I've got a 1-inch mill in the holder, and we're going to cut a 1-inch diameter, a 1/2-inch radius on the end of this 1/2-inch rod that will match the radius of the sliding, the tube part of the control. This is a roughing mill. It doesn't give a very smooth finish. It's for hogging out material, but it's what I had in the end mill holder, and for this purpose it doesn't need to be a perfectly smooth finish. But you can see that it has the 1-inch diameter, 1/2-inch radius. All right, we're going to swap out for a 3/4 inch and do the other shaft. So we're still on the center line. I've swapped out the stub shaft to the other one. This is in a 3/4 inch roughing mill. Doesn't look like a whole lot of difference, but the top one's 1 inch, the bottom one's 3/4. I've got the first of the 2 stub shafts. This one is on the inner shaft, the 3/4 inch shaft. So this is for the rear hydro, which drives the left side of the tractor. Got a little magnet here holding it vertical. The linkage is in approximately the midpoint of its travel. So I'm going to tack this. Now these, I recognize that these stub shafts are offset to the left. Been thinking about how to bring them back on center line. And I may do that with the actual shafts. I may eventually cut these off, I'm not sure. I'm leaving them long just in case. Not sure how long I want them, so better leave them long. I can always cut them off. I may take the tubing, the handles, and bring the handles up at an angle and then vertical so that the actual handles themselves are centered. I have to move everything over about an inch, inch and a half, something like that. So I'll think about doing that. It's not bad that they're off center. I might wind up putting another control here on this, you know, to the right of them. Perhaps one of the blade controls or a blade control. I'm thinking maybe a 4-way valve with a float detent, similar to what you would use on a front end loader valve, that would allow me to manipulate the blade in at least the 4 different directions and then get it to float as when back dragging, for example. So it's kind of my thought process at this point in time, and having it here with these offset would work fine, potentially. Okay, I'm going to go ahead and tack this, weld this up. I think both of those are close to the midpoint. I think this one's probably closer than this one, but like I said, they're adjustable with the turnbuckles. All right, I'm going to put a little more weld material, a little more weld on this one. This one I was able to get on 3 sides. This one I was only able to get on 2 sides. So I'm going to build up a little bit of weld metal here. Just there's a little more inherent friction in this lever. I think due to the proximity of the weld metal to the, maybe a little bit of spatter in there that is causing some friction. When we apply the friction clamps here, it'll even it out. Okay, so I think our controls are in good shape here. Maybe we get a sprocket on when the sprocket comes. I ordered the other sprocket and more chain. I think I mentioned that. Maybe we'll be able to test it out. I'll put a drill on the control, on the drive shaft, and we'll check out the controls. But seems to be in good shape there. Okay. Now that I've got the seat riser drilled and I'm accommodating these seat mount brackets, so this will go right there. Bolt will go through it. Probably tack weld it. Since it's only one bolt, I can't put bolts up here that interfere with the pivot. There's really no place to put another bolt. I mean, I could weld something in here maybe, but well, I can't weld it because then I can't get the seat off. So I may have to weld a piece across here to put a second bolt. So I need to transfer those points to the other side. 11:30 seconds. Okay, so let's redo this hub here. So we're going to change out the studs I'd used previously, which don't really fit properly. We're going to replace them with studs driven in from the back. Chase all the threads. Alright, so I got shorted one lug nut. One of these is I believe 3/4 of an inch. Yeah. Alright, so the one lug nut is actually for a 1/2 inch stud. It's supposed to be 7/16. Get a magnet or something to get it out of there. Alright, I'm not going to put the other spacer on since I've got that loose lug nut in here someplace. It's the wrong size. Okay. Alright, I'm getting ready to cut out some more parts for the dozer. These parts are for the idler wheel, one of the idler wheels. I'm prototyping the idler wheel in 1/4 inch. I'm not sure whether I'm going to stay with 1/4 inch or move up to 3/8 for the actual wheels. I'm going to build one in 1/4 inch and see how it looks. I've got to cut some spacers out, so I'm going to be cutting some 6-inch diameter spacers, and then also the 13.5 inch diameter wheel, which will be used, actually they're discs which will be used to build the wheel. A pair of discs and spacers to make the wheel. So we'll cut some steel out right now. Alright, so there's the spacer. I'll show you how this will be used in a few minutes. Alright, so that's one side of the idler wheel. And there'll be a spacer and then another one identical to this or similar to this on the other side. Alright. Alright, so here's the second piece of the idler wheel. And I'll show you how this goes together, or at least how I hope it goes together. Several folks had suggested I use an air chisel to take the dross off, and I have to say that, man, I could hook up my air chisel. I do have one, and my air compressor is charged, so I could do that, but this worked fine. I mean, there may be a couple of spots that need to be sanded to be perfectly smooth, but all right, here is the setup for the idler wheel. This goes on the studs. This is a spacer. It's another spacer. Another spacer. And then that's the outside. So I've already discovered a minor problem. So I don't know how I did this. I thought I discovered this problem in Fusion 360 and I thought I fixed it. Anyway, when these stud holes, when they're aligned, these gaps need to also be aligned. So I need to go back in and figure out why that isn't so. But in any case, how it's supposed to go together, these two on the studs, this goes on, lines up with those, spacer there, and then this. And these large holes let me reach the studs to fasten it. And the spacers are needed to get the proper width here for the chain. So let's stick this on. And the plan is then to weld plates. A plate here, between the two large discs. A plate here, a plate here. So those plates will provide the inside, bottom of the inside track for the chain. Let's go ahead and put this on. I won't be able to the chain will fall down inside here because there's no plates at every, at the 8 different places, but we'll work on that. Okay, so let's assemble an idler here. This then is an idler wheel, and I have to have these holes here to reach these studs, because once I weld plates across these openings to create a bottom basically for this groove, I won't be able to reach, won't be able to, the whole thing will have to come off as an entire piece. This spacer in the middle will be captured. This spacer here will be captured between these two outer plates, so I need to access the studs there. Okay, let's see how the chain fits on this. All right, so that you can see the chain then fits. There's a little bit of clearance between those plates. Looks like about 1/8 of an inch or something like that. But it certainly works. I think that'll work as an idler. And just from the, I'm basically thinking the quarter inch plate is going to be plenty strong for this application, especially when I weld the bottom plates across, in these spaces. So there's a mock-up prototype of the first idler wheel. So I need 2 idler wheels like this, one on this corner, one on the right rear corner. The only other thing I need to do is adjust the spacing so that the track is centered on the idler wheel and the sprocket. That is, it's a straight line. Clearly now it's not, because this is out about 1 inch further than the center of the idler. So I have some 1.5 inch spacers coming. So what I'll probably do is swap one of these out for an 1.5 inch spacer, maybe both of them, and that'll bring this in 1 inch. I have to do a calculation, or at least a measurement here, to make sure they're spaced properly. I may have to add a spacer up there. Maybe that will be easier to do, is add a spacer to the front, maybe 1/2 inch, and maybe bring this in 1/2 inch. Don't want to bring them in a whole lot further, because then I lose my footwell spacing. Okay guys, that's all we've got time for this week. We've accomplished a lot. Got the idler components, wheel components cut out. I do need to make an adjustment on one of them. I'll cut out the others. Next time we come back, we'll assemble the idler wheels, adjust the spacing on the idler wheel to match the sprocket, or vice versa, and then be looking at the track frame. And I've got the steel. I believe I've got the pieces of steel I can use to build that. We'll come back with a look at that frame, and how that and the tensioner will work, or at least start thinking about how we're going to build the tensioner. I think the tensioner should be, we want it to look right, probably the same diameter as the idler. I think on the D10 it's actually larger, but we'll look at that and see what makes sense, and we'll go from there. Appreciate everybody watching and all your comments. They're great. I try to answer as many questions as I can. Hit the thumbs up and subscribe if you haven't already, so you don't miss future episodes. And we'll see you guys next time.